So we all know about electromagnetic waves, right? So this is the wave in which you are going to transmit our information in the air, right? So uh, what happens to this electromagnetic waves when it travels in the air? Okay, there may be an obstacles like buildings, trees, mountains. Okay, so this electromagnetic waves will hit the obstacle, and the portion of your electromagnetic energy is absorbed by the obstacle itself. Okay, and the portion of the electromagnetic wave only get reflected, and some of the electromagnetic waves is refracted into that material itself, right? So that's that type of concept only we are going to discuss. So for example, if I take two medium, okay, for example, this is my medium 1, in which the permittivity and permeability, okay, so this epsilon is nothing but we call it as permittivity, right? And mu is nothing but permeability. Okay, so one is with respect to the magnetic field, the another one is with respect to the electric field. Okay. Because your electromagnetic waves is going to is composed of electric field and magnetic field that they uh, travel perpendicular to each other, right? Both electric field and magnetic field will travel perpendicular to each other, and they travel perpendicular to the direction of propagation. Okay, okay, so each medium has its own permittivity and permeability. Okay, so this is my medium 2 with permittivity epsilon 1 and permeability mu 1. Okay, for example, uh, this is a perfect conductor. So if it is a perfect conductor, then you cannot have a specific value for this one. So perfect conductor. Okay, now your electromagnetic waves hit this perfect conductor with an angle of theta I. Let it be the angle of incidence for this electromagnetic wave is theta I, and you are transmitting with with a power of pt. Okay, suppose if it is a perfect conductor, what it will do is it will reflect all the energy into the medium one itself. Okay, so this is the angle of reflection. Okay, let it be theta r, and it is transmitting some amount of power that is denoted by reflected power. Okay, so we draw a tangent line to our perfect conductor. Okay, a perpendicular line. Okay, uh, with that one we are trying to find what is the angle of incidence and what is the angle of reflection, theta I and theta r. So in case of perfect conductor, the angle of incidence is equal to angle of reflection. So theta I is equal to theta r. Okay. Suppose if it is a dielectric medium, in case if it is a dielectric medium, medium 2, this is with epsilon 1 and mu naught, and this is a dielectric and this is also dielectric with an epsilon 2 and mu naught. Okay, so mu naught going to be the same for both dielectric material. It is same for both cases. So if it is a dielectric medium, and when you pause an electromagnetic waves, the This is my angle of incident, and it is transmitted with a power PR. Some of the waves get transmitted into this medium, okay, with an angle of theta r with a power of PR. Okay, right. So some of this incident waves is transmitted into the medium, that we call it as a refracted wave. So this angle, let it be denoted by theta t, angle of refraction. This we call it as angle of refraction. சரிங்களா? And this here, in this case, this will not be equal. Theta I will not be equal to theta t. Okay, it is based upon your medium, right? It may be greater than theta I, or it may be less than or theta t. Okay, now what is the velocity with which it travels in the medium 1 and medium 2 is determined by 1 over square root of mu naught epsilon 1 and v2, which is nothing but 1 over square root of mu 1 epsilon 2, sorry, mu naught epsilon 2. So this is the velocity expression for our electromagnetic wave when it travels with the medium 1 and medium 2. Okay, so from this we are trying to find what is our Snell's law. So Snell's law will gives you the relationship between angle of incidence and angle of refraction. Angle of incidence and angle of refraction. So it gives you the relationship between the angle of incidence and refraction. So just nothing but sine theta t divided by sine theta I. Okay, this is refracted and this is incident, which is equal to v2 by v1. v2 by v1. So what is v2? V2 is nothing but 1 over square root of mu naught epsilon 2. And what is v1? 1 over square root of mu naught epsilon 1. So this is equal to square root of epsilon 1 divided by epsilon 2. So in some case, you can write it as in terms of epsilon r1 divided by epsilon r2 also. Okay, the another notation is epsilon r1. Okay, so this is our Snell's law. Snell's law will tell you the relationship between your incident wave and the refracted wave. Okay, so if you are given with the epsilon values, then you can easily determine what is our theta I and theta t. The next important definition is index of refraction. So what is meant by index of refraction is, it is nothing but a ratio of velocity of propagation in a vacuum to the velocity of propagation in a particular medium. So index of refraction is mainly used in our optical communication. So we will discuss detailing this index of refraction in our optical communication module. Okay, so here n1 is nothing but epsilon r1 and n2 is nothing but epsilon r2. Therefore sine theta t divided by sine theta I, which is equal to n2 divided by n, sorry, this is n1 by n2, n1 divided by n2. Okay, so we defined Snell's law and index of refraction in terms of uh, permeability, right? Okay, so now we will do some problems based upon this concept. So the first one is, take down this one. An electromagnetic wave propagating in air, encounters a boundary with a material having a dielectric constant of 4. Okay, the angle of incidence in air is 60 degree. Determine the angle of refraction. Okay, so this is the problem statement given to you. We have to find the solution for this one. So we have to find the angle of refraction only. Okay, that is theta r. So what do you know about the Snell's law? It is nothing but theta t divided by sine theta r, which is equal to n1 by n2, right? That is what we know. And you are given with dielectric constant of 4 and the angle of incidence is 60 degree. So angle of incidence is, sorry, this is theta I. Theta I information is provided, and your n1 is nothing but your wave is propagating in air. If it is propagating in air, then you can take your dielectric constant as n1 is equal to 1. That is your index of refraction is equal to 1. And what is my n2? N2 is equal to 4. So n2 is equal to, that is square root of epsilon r2. Right? So square root of epsilon r2 is nothing but square root of 4, which is equal to 2. So now comes here sine theta t is equal to sine theta I into n1 by n2. So sine 60 degree into 1 over 2. So now tell me the final answer for this one. Tell me the value for this one, and then take inverse of this value. Sine inverse of sine 60 degree into 1 over 2. How much you will get? Theta t என்ன வருதுன்னு பாருங்க பார்க்கலாம். The angle of refraction என்ன வருதுன்னு பாருங்க. How much you are getting? Theta t. Theta t என்ன போறது? Angle of refraction. The answer is 25.65. Very good. So you will get around 25.65. Okay. Okay. So we are not going in depth of this physical phenomenon. Okay. And some of the topics are ground wave reflection and sky wave propagation. So these are all topics you can study by yourself only. Okay. Sky propagation. நீங்களே படிச்சிருங்க. ஓகேங்களா? Very simple only. Ground wave propagation. Okay. So this is all theory part. You can just read it. That is enough. Okay. So now we will do some problems. Take down this problem. Compute the Doppler frequency measured by the radar shown in the figure below. Okay. So what you have to find? You have to find what is the Doppler frequency. Okay, Doppler frequency is nothing but FD. Yeah, FD. So you know the formula for finding FD. Can anyone say what is the formula for finding FD?
V by C into FC, sir.
சொல்லுங்கப்பா. V by
V by C into FC, sir.
V by C into FC. அவ்வளோதானா? இன்னும் ஒரு டேர்ம் வரணுமே. டாப்லர்
Two. Two
2 and
into
2 times. Very good. Because it is a two-way path. So அதனால 2 ஆல மல்டிப்ளை பண்ணணும். So 2 into V by C into FC, right? So this is a radar, okay, in which the wavelength is given by 0.03 meter. Okay, and the velocity of this radar is 250 meter per second. Okay, right. So there will be a radar present in your aircraft itself. Similarly, there is another radar which comes towards this radar. Okay, this is the line of sight between this two radar. This you consider it as a target. Okay, this is my line of sight. Okay, LOS, and this is coming at a velocity of இதோட velocity பார்த்தீங்கன்னா 175 meter per second. It is 175 meter per second. So from this information, can you find what is FD? Can you find FD? FD கண்டுபிடிக்க முடியுமா? FD formula is 2V by C into FC, the carrier frequency. Okay, here whether carrier frequency information is present in our problem. Carrier frequency information நம்ம ப்ராப்ளத்தில் இருக்காப்பா?
இல்ல சார்.
ஓகே, அதுக்கு பதில் என்ன கொடுத்துருக்காங்க? ஏதாச்சும் இன்ஃபர்மேஷன் இருக்கா?
லேம்டா கொடுத்துருக்காங்க.
வெரி குட், லேம்டா கொடுத்துருக்காங்க. ஸோ C is equal to F into lambda, right? அப்போ lambda is equal to C by F, right? So I can rewrite this FC by C as 2V by lambda போட்டுக்கலாமா? அப்போ lambda information எனக்கு கிடைச்சிருச்சு. இப்போ வாட் இஸ் திஸ் வெலாசிட்டி? இந்த வெலாசிட்டி என்ன சப்ஸ்டிட் பண்ணுவீங்க? 2 by 0.03. இந்த வெலாசிட்டி என்ன சப்ஸ்டிட் பண்ணலாம் சொல்லுங்க பார்க்கலாம். ரெண்டு டார்கெட் இருக்கு. ஓகே, ஸோ ரெண்டு there are two targets which moves towards each other. Okay, but this is going to transmit a waveform. இதோட வெலாசிட்டி வந்து 250 மீட்டர் per second. இதோட வெலாசிட்டி வந்து 175 மீட்டர் per second. So how do we find the velocity for this one? இந்த மாதிரி ரெண்டு டார்கெட் மூவிங் ஆயிருந்துச்சுன்னா என்ன கண்டுபிடிக்கணும்னா you have to find the relative velocity. என்ன கண்டுபிடிக்கணும் நம்ம? We have to find what is the relative velocity of this two target. If it move towards each other, ரெண்டுமே move towards each other means then what we have to do is we have to add their velocities. If they move away, okay, one இங்க இருக்கு, இன்னொன்னு move away இருந்துச்சுன்னா then you can subtract their velocity v1 minus v2. Okay, சரியா? ரெண்டுமே மூவ் ஆயிட்டு இருந்துச்சுன்னா என்ன பண்ணணும்? You have to find the relative velocity of this one. If it towards, ரெண்டுமே towards இருந்துச்சுன்னா என்ன பண்ணணும்? We have to add it. If they are far away, ஒன்னு towards இருக்கு, இன்னொன்னு வேற டைரக்ஷன்ல போச்சுன்னா you have to subtract it, right? So here what you will get? இப்போ நமக்கு என்ன வரும்? We have to add 250 plus 175. இது ரெண்டையும் ஆட் பண்ணிட்டு கால்குலேட் பண்ணுங்க. Okay, very simple only. Answer சொல்லுங்க பார்க்கலாம். How much frequency shift you will get? எவ்வளோ போகிறோம்? 2/0.03 into 425. You will get an answer of, யாராச்சும் ஆன்சர் போட்டிருக்கீங்களா? How much you will get?
Sir, 28,000.
28.33 kilohertz. Very good. So you will get around 28.33 kilohertz வருதா? So this is the Doppler shift for this case. Okay, very simple தான். ஒன்லி திங் இப்போ என்ன பண்ணா, ரெண்டுமே மூவ் ஆகுறதுனால ரிலேட்டிவ் வெலாசிட்டி கண்டுபிடிச்சோம், வேற ஒன்றுமே கிடையாது. சரியா? இப்போ இன்னொன்று ஒரு ப்ராப்ளம் தரேன். இப்போ இதுக்கு நீங்கள் தான் கண்டுபிடிக்கணும். கன்சிடர் த சிச்சுவேஷன், consider the situation shown in figure with Doppler radar operating at 12 gigahertz. Okay, so your radar is operating at a frequency of 12 gigahertz. If the frequency shift is 1 kilohertz, okay, then determine the speed of the car in miles per second. ஓகேங்களா? என்ன பண்ணணும்? மைல்ஸ் பெர் செகண்ட்ல கண்டுபிடிங்க. வாட் இஸ் த ஸ்பீட் ஆஃப் யுவர் கார்? Okay, so your car is moving like this. I am not able to draw the car picture. It is moving in this direction. For example, it is moving in the angle of 60 degree. Okay, right. This is your Doppler radar. Right, and it moves in move to a distance of x. சரிங்களா? இப்போ மைல்ஸ் பெர் அவர், ஸோ இந்த லாஸ்ட் கிளாஸ்லேயே நமக்கு ஒரு சின்ன கன்ஃபியூஷன் வந்துச்சு இல்லையா? ஸோ 1 mile is approximately equal to, so how much you will get? 1 mile is equal to 1 points, otherwise in terms of meter per second எழுதுனீங்கன்னா 1609.34 meter per second. ஓகேங்களா? ஸோ நம்மக்கிட்ட எவ்வளோ இருக்குது? 3 × 10⁸ meter per second இருக்குது. ஸோ convert this into miles per second. Approximately take this value 1,86,000 miles per second. ஓகேங்களா? இது அப்படியே கன்வெர்ட் பண்ணிடுங்க. இந்த 1 mile is equal to 9.34 meter per second. ஸோ 3 × 10⁻, meter per secondல எவ்வளோ மைல்ஸ் இருக்குன்னு பார்த்தீங்கன்னா 1,86,000 miles per second. ஓகே, ஸோ இந்த வேல்யூ வச்சு நீங்கள் ப்ரொசீட் பண்ணுங்க. ஓகே, இப்போ வெலாசிட்டி எப்படி கண்டுபிடிங்க? வாட் இஸ் த ஃபார்முலா ஃபார் ஃபைண்டிங் த வெலாசிட்டி? What is our Doppler shift? Doppler shift is nothing but 2 v/c into fc. ஓகேங்களா? இதில் நம்ம என்ன கண்டுபிடிக்கணும்? we have to find what is the velocity. Velocity is equal to c into fd divided by 2 times fc. Okay, so in the place of velocity, substitute this 186,000 into, what is our fd? Doppler shift is 1 × 10⁻³ divided by 2 into, what is fc? It is nothing but 12 into 10 power of 9, right? So since it is gigahertz, you have to take it as 10⁻⁹. இதில் எவ்வளோ வருதுன்னு பாருங்க பார்க்கலாம். இதோட ஆன்சர் என்ன போகிறது? And then after that, we will convert into miles per hour. இது miles per second கிடையாது, so write it in terms of miles per hour. Okay, first try to find the velocity in terms of miles per secondல கன்வெர்ட் பண்ணுங்க, அதுக்கப்புறம் miles per hour அதுக்கப்புறம் கன்வெர்ட் பண்ணிக்குவோம். இப்போ எவ்வளவு போகுது velocity? How much you are getting velocity? இது புரியுதா? இதுல ஏதாச்சும் டவுட் இருக்காப்பா? நான் அந்த 3 × 10⁸ வந்து 1,86,000 மைல்ஸா மாத்திட்டேன். நான் மாத்திட்டு அதுக்கப்புறம் ப்ரொசீட் பண்றேன். நான் any doubt how much you are getting for velocity? You got answer, very good. 7.75. Yeah. 7.75 into 10⁻³ miles per second. Correct தானா? 1860600 into we have missed one point. இதுல நம்ம ஒரு பாயிண்ட் மட்டும் மிஸ் பண்ணிட்டோம். என்னன்னு சொல்லுங்க பார்க்கலாம். இந்த ஆங்கிளை நம்ம கன்சிடர் பண்ணவே இல்லை. கரெக்டா? We have missed this point. It is moving in the angle of 60°. The formula இங்க இருக்கு, நியூமரேட்டர்ல இருக்கு cos theta. Okay, in terms of v போட்டீங்கன்னா this cos theta will comes below, right, in the denominator. It into cos theta. Correct. Cos theta கீழ வந்து cos theta is 1/2. 1/2 போட்டு பாருங்க. 27 point missing. அந்த cos theta மட்டும் போட்டீங்கன்னா ஆன்சர் வந்துரும். ஆன்சர் very simple. ஒரு 1/2 மட்டும் தான் வருது. எவ்வளோ வருது? 15.1. கரெக்ட். 15.5 into 10⁻³ miles per second. ஓகே, miles per hour கன்வெர்ட் பண்ணீங்கன்னா கரெக்ட். ஸோ த ஆன்சர் given by முருகன் இஸ் கரெக்ட். 55.94 miles per hour. ஓகே, அதை ஹவரை கன்வெர்ட் பண்ணிடுங்க. இன்ட்டு 3600 போட்டிங்கன்னா அது மைல்ஸ் per ஹவராக மாறிடும். சரிங்களா? அருண் கார்த்திக், ப்ளீஸ் மல்டிப்ளை தட் ஒன் வித் 3600. 3600 மல்டிப்ளை பண்ணீங்கன்னா you will get an answer of 55.94 miles per hour. Whatever the answer you are getting, so multiply with 3600. You will get an answer of 55.94 miles per hour. சரிங்களா? Okay, so how much we have completed in our telecom? So we'll go back to our syllabus part. So far we have covered up to this point, right? We have covered our introduction part, and then communication link analysis, radar link equation, Doppler radar equations. Okay, so far we have completed up to this point, right? So for this syllabus portion, we will conduct a revision in the next class. Okay, so next class la revision மட்டும் பண்ணுவோம். ஒரு